A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. Alright, we are diving into the plumbing today. Today's prompt from Daniel is about the state of CI/CD tools in 2025, and it is a massive landscape. We are moving way beyond the just use Jenkins era, though as Daniel points out, the old Titan is still very much in the room.
It is the ultimate can't live with it, can't live without it software. Herman Poppleberry here, by the way. I have been looking at the data for this year, and what is fascinating is how much the one-size-fits-all model has just completely shattered. We have gone from a world where everyone tried to force their workflow into one tool to a world where teams are picking highly specialized engines based on whether they are cloud native, mobile, first, or enterprise legacy.
It feels like the stakes have shifted too. It used to be just about, did the build pass? Now, it is about security scanning, cost orchestration, and whether your pipeline can handle 1,000-node Kubernetes clusters without falling over. Oh, and fun fact before we get too deep into the weeds, today's episode is actually powered by Google Gemini 3 Flash. It is the one helping us organize this massive survey of tools.
Which is fitting, because AI is starting to creep into these pipelines in ways we will talk about later. But let's start with the elephant in the room, Jenkins. It was released in 2011, 14 years ago, and yet, if you look at the 2025 surveys, it is still sitting there with a massive market share.
It is the COBOL of DevOps. You want to hate it. You want to move away from it. But every time you try, you realize you have 10,000 lines of groovy script that no one wants to rewrite. Why does it persist, Herman? Is it just inertia, or is there a technical moat there?
It is the plugin ecosystem. That is the paradox. Jenkins has over 1,800 community-contributed plugins. If you have some weird, obscure mainframe from the 90s that needs to trigger a deployment to a private cloud in a bunker, there is a Jenkins plugin for that. But that is also its downfall. We call it plugin hell for a reason. You update one security patch, and suddenly your entire build fleet is offline because of a version mismatch in a plugin that hasn't been maintained since 2018.
I have seen teams try to solve that with the Jenkins configuration as code movement, basically trying to treat the Snowflake server like a disposable container. Does that actually work in practice, or is it just putting a tuxedo on a donkey? No offense to your species, Herman.
None taken. I am a proud donkey, and even I know when a load is too heavy. Jenkins configuration as code, or JCASC, is a valiant effort. It allows you to define your entire Jenkins master plugins, security realms, nodes, and a YAML file. It definitely makes it more reproducible. But at the end of the day, you are still managing a stateful server. You still have to worry about the JVM heap size, the disk space for build logs, and the zombie workers that refuse to disconnect.
Which is exactly why the world moved toward GitHub Actions and GitLab CI. It feels like these two have basically captured the default spot for any new project. If you were starting a company in 2025, are you even looking at anything else?
For most people, no. GitHub Actions in particular has seen explosive growth, something like 40% year-over-year growth in workflow runs recently. The reason is simple: proximity to the code. If your code lives on GitHub, why would you go through the friction of setting up a separate CI server, managing webhooks, and dealing with cross-tool authentication?
It is the good enough trap, right? It might not be the most powerful engine, but it is right there. It is like the microwave in your kitchen. You could go to a 5-star restaurant, but the microwave is 3 feet away and it gets the job done in 2 minutes.
That is a fair comparison, but GitHub Actions has actually become quite a powerful microwave. Their Actions marketplace has essentially replaced the Jenkins plugin library, but with a much better security model. Because each action runs in its own isolated container or environment, you don't get that plug-in hell where one bad script takes down the whole system. What is really interesting is how GitLab CI approaches it differently. GitLab isn't just a tool, it is a unified DevSecOps platform.
They love that term. Single application for the entire lifecycle.
They do, but they back it up. GitLab's integrated container registry, security dashboards, and built-in Kubernetes clusters make it feel much more cohesive than GitHub's collection of parts approach. If you are a high-compliance organization, think banking or healthcare, GitLab's self-managed version gives you a level of control over the data residency and the kill switch that GitHub's cloud-first model sometimes struggles with.
So we have the legacy titan and the integrated giants. But then there is this whole other world that has emerged in the last few years, the container-first, Kubernetes-native stuff. I am talking about Tekton and Argo workflows. This feels like a different philosophy entirely. It is not just running a script, it is orchestrating a cluster.
This is where we get into the heavy engineering. Tekton is fascinating because it is built on Kubernetes Custom Resource Definitions, or CRDs. In a traditional CI tool, the pipeline is a proprietary concept the tool understands. In Tekton, a task or a pipeline is literally an object in the Kubernetes API.
So you are saying the cluster itself knows how to build software?
Precisely. You aren't running a Jenkins agent that then runs a Docker command. You are telling Kubernetes, here is a task run object, go fetch this container and execute these steps. This allows for incredible dynamic composition. You can scale your CI infrastructure using the exact same tools you use to scale your production app. Horizontal pod autoscalers, spot instances, the works.
I remember reading a case study about a SaaS company that migrated from a massive Jenkins cluster to GitHub Actions, and they cut their maintenance time by 60%. But if you go from GitHub Actions to something like Tekton, does the complexity go back up? It feels like you need a PhD in Kubernetes just to print "Hello World."
The complexity definitely shifts. You are trading maintenance of a Snowflake server for maintenance of a platform. If you are a 5-person startup, Tekton is overkill. You will spend more time debugging your YAML than writing code. But if you are a platform team at a Fortune 500 company supporting 5,000 developers, Tekton is a godsend. It gives you a standardized white label foundation that you can build your own internal developer platform on top of.
And then there is Argo workflows. I see Argo mentioned constantly in the same breath as GitOps. Is it a CI tool, a CD tool, or just a general purpose do things in order tool?
It is a container-native workflow engine. While Tekton is very focused on the build, test, deploy cycle, Argo is broader. It is used for machine learning pipelines, data processing, and complex multi-step deployments. According to recent data, over 60% of Fortune 100 companies are using Argo for their Kubernetes-native automation. The killer app there is Argo CD, which implements the GitOps pattern. It watches your Git repo and ensures the cluster state matches the code. If someone manually changes a setting in the cluster, Argo sees it and heals it back to what the code says.
That is a huge shift in mindset. We used to push code to a server. Now the cluster pulls the desired state. It is like the difference between me throwing a ball at you and you just deciding you want to be holding a ball and then making it manifest in your hands.
That is a very sloth-like way of looking at physics, corn, but it is accurate for software. Now, we should mention the commercial powerhouses because they are still doing some very cool things. Circle CI, Travis CI, Bitrec, Bitrus. People often ask why they should pay for these when GitHub Actions is free for many.
Free often means you spend 40 hours a month fixing your own runners.
That is the value proposition. Take Circle CI. They have spent years optimizing the speed to feedback loop. Their orb system is great, but the real edge is in the runner optimization. Things like test splitting, where the tool automatically looks at your test suite, calculates which tests take the longest, and balances them across parallel containers to ensure the build finishes in the shortest time possible.
I have seen teams try to do that manually with scripts, and it is a nightmare to maintain. You end up with one container that finishes in 2 minutes and another that takes 20, and your whole pipeline is stuck waiting for that one slowpoke.
And then you have Bitrus, which has basically become the default for mobile development. Building iOS and Android apps is a special kind of torture. You need macOS runners for Xcode. You need to manage provisioning profiles, certificates, and Play Store keys. Bitris handles all of that mobile-specific friction. If you are building a React Native or Flutter app in 2025, you are almost certainly using Bitris or maybe CodeMagic, because the general-purpose tools just don't have the specialized hardware and software stacks ready to go.
It is the abstraction tax. You pay a premium so you don't have to think about the underlying mess. But what about the engine-agnostic movement? I've been hearing a lot about Dagger lately. Solomon Hykes, the creator of Docker, is behind it, right?
Yes, and Dagger is trying to solve the it works on my machine problem once and for all. Think about it. Right now, your CI pipeline is usually written in some proprietary YAML GitHub. Actions YAML, GitLab YAML, Circle CI YAML. If you want to run that same logic on your laptop to debug a failing test, you can't. You have to commit, push, and wait 10 minutes for the CI to run.
It is the most frustrating part of being a developer. The commit, push, praise cycle.
Dagger changes that by moving the logic out of the YAML and into code, Python, Go, or TypeScript. You write your pipeline as a script using the Dagger SDK. That script runs in a containerized engine. Because the engine is portable, you can run the exact same command on your MacBook and in the GitHub Actions runner. The YAML just becomes a trigger that calls the Dagger script.
That feels like a return to the build script era, but with 21st century containerization. It is like we realized that YAML isn't a programming language, and we finally decided to go back to actual code.
It is the pipeline as code versus pipeline as data debate. YAML is data. It is great for simple things, but as soon as you need a for loop or complex conditional logic, YAML becomes a mess of nested strings and custom tags. Dagger says, just use a programming language. It also has this incredible action caching system. It calculates a hash for every single step in your build. If you haven't changed the files relevant to a specific step, Dagger just pulls the result from the cache even if you are running it on a completely different machine.
That could be a game changer for monorepos. If I have a massive repository with 50 microservices and I only change one line in one service, I don't want to rebuild the other 49.
And that brings us to the specialized delivery tools. We have talked a lot about the CI part, continuous integration, but the CD part, continuous delivery, is where things get really hairy at scale. That is where Spinnaker comes in.
Spinnaker is the Netflix tool, right? It always sounded a bit like a Death Star of deployment tools. Massive, powerful, but maybe a bit dangerous if you don't know what you are doing.
It is definitely an enterprise-grade weapon. Spinnaker was designed for multi-cloud deployments. If you need to deploy the same application to AWS, Google Cloud, and an on-premise OpenStack cluster simultaneously, while doing a canary deployment where only 1% of traffic goes to the new version, Spinnaker is the only tool that handles that natively.
Explain the canary thing for a second, because I think people hear these terms but don't realize how much engineering goes into them.
Sure. In a traditional deployment, you just swap the old version for the new one. If the new one has a bug, everyone crashes. In a canary deployment named after the canary in the coal mine, you deploy the new version to a tiny slice of your infrastructure. Spinnaker then automatically monitors your metrics, error rates, latency, CPU usage. If it sees that the canary version is performing worse than the baseline version, it automatically rolls back the deployment before most users even notice.
That is the reliability part of the equation. But man, the setup for Spinnaker is legendary for being difficult. I think I once saw a diagram of its architecture, and it had like 12 different microservices just to run the deployment tool itself.
It is a lot to manage. That is why we are seeing a shift toward managed Spinnaker or tools like Harness. Harness takes that automated canary and AI-driven rollback logic and provides it as a SaaS. They are leaning heavily into the AI aspect Daniel mentioned in his notes.
Alright, let's talk about the AI. It is 2026, everything has AI slapped on it. Is there actual substance here in the CI/CD world, or is it just a marketing gloss?
There is some real substance, particularly in predictive build failure and log analysis. Imagine you have a test suite that takes 2 hours to run. An AI-integrated CI tool can look at the code changes you just made and say, statistically, these changes only affect these 3 modules. I am going to run those tests first. Or even better, Based on past failures, this change is 90% likely to break the integration test in the checkout module. I am going to alert the developer before the build even starts.
That is actually useful. It is like having a very obsessive senior developer looking over your shoulder. What about the log analysis? Because staring at 50,000 lines of Jenkins console output is my personal idea of hell.
That is exactly where LLMs shine. Tools are now starting to pipe build failures into models that can summarize the error. Instead of exit code 1 followed by a stack trace, you get the build failed because you updated the library version in line 42 of the package file, but you didn't update the initialization call in the main class. It can even suggest the fix or open a pull request to correct it.
I can see the security side of this being huge too. We are seeing tools like Snike and Aqua Security being integrated directly into the pipeline. It is not just about, does it run? It is about, is it a ticking time bomb?
The shift left movement is in full swing in 2026. We are moving security scanning from something we do once a quarter to something that happens every time you save a file. This is where Azure DevOps is actually a secret weapon for many large organizations.
Daniel mentioned Azure DevOps being popular for large teams. It always felt a bit corporate to me, but I guess if you were an all-in Microsoft shop, it makes sense.
It is incredibly cohesive. If you are using Azure for your cloud, Active Directory for your identity, and Teams for your communication, Azure DevOps ties it all together. It handles your boards, your repos, your test plans, and your pipelines in one interface. For a project manager at a large bank, that one pane of glass is worth its weight in gold. They don't want to hunt through 5 different tools to see if a feature is ready for release.
So we have covered a lot of ground. We have the old guard in Jenkins, the new defaults in GitHub and GitLab, the Kubernetes natives in Tekton and Argo, the mobile specialists like Bitrus, the portable engines like Dagger, and the enterprise shifters like Spinnaker and Azure DevOps. If you are a developer listening to this, how do you even begin to choose?
I think you have to look at your constraint first. If your constraint is, I have 0 time to manage infrastructure, you go with GitHub Actions or a managed service like CircleCI. If your constraint is, I have massive complex deployments across multiple clouds, you look at Spinnaker or Harness. If your constraint is, I need my local development to match the CI exactly, you look at Dagger.
And if your constraint is, I have 10 years of legacy scripts and no budget to rewrite them, you stay on Jenkins and maybe try to clean it up with JCASC.
I mean, you are right. Sorry, I almost used the forbidden word there. You are spot on. One thing we haven't touched on is the cost aspect. In 2025, cloud bill shock from CI/CD is a real thing. These tools are so easy to scale that you can accidentally spend $10,000 in a weekend because someone triggered a recursive build loop.
I have been there. It is the DevOps equivalent of leaving the garden hose running while you go on vacation.
This is driving a trend toward self-hosted runners on public clouds. Teams are using tools like Actions Runner Controller for Kubernetes. It allows you to use the GitHub Actions brain in the cloud, but the actual brawn, the compute power, runs on your own servers or on cheap spot instances that you control. It is a middle ground between the convenience of SaaS and the cost control of self-hosting.
It feels like the industry is maturing. We went through a phase of automate everything at any cost, and now we are in the automate intelligently and sustainably phase. Which brings up a question. What does the tool of 2030 look like? Are we even going to be writing pipelines in 5 years?
I think the pipeline as we know it will start to disappear. We will move toward intent-based delivery. Instead of telling the computer, step 1, build. Step 2, test. Step 3, deploy, we'll say. Ensure this code is running in production with 99.9% availability and no high severity vulnerabilities. The underlying orchestrator, which will be heavily AI driven, will figure out the necessary steps to make that happen.
That sounds amazing and terrifying. It is the ultimate no-ops dream, but we are still a long way from that. For now, we are stuck with YAML and Groovy and the occasional, why is this build still pending? Frustration.
It is a journey. But the tools we have now are light years ahead of what we had even 5 years ago. The fact that a single developer can set up a global deployment pipeline in an afternoon using GitHub Actions is a miracle of modern engineering.
Alright, let's wrap this up with some practical takeaways. If you are a listener and you are feeling overwhelmed by this survey, here is the Korn and Herman cheat sheet.
Number 1. If you are starting a new project and your code is on GitHub or GitLab, just use their built-in CI, period. Don't overthink it. You can always migrate later if you hit a wall, but the speed of starting is more important than finding the perfect tool.
Number 2. If you are feeling the pain of, works on my machine but breaks in CI, look at Dagger. Even if you don't move your whole pipeline there, using it for your most complex build steps can save you hours of debugging.
Number 3. If you are running on Kubernetes and you find yourself struggling with scripts inside containers, look at Argo workflows or Tekton. Embrace the native way of doing things rather than fighting the cluster.
And number 4, if you are doing mobile, just go to Bittrees. Don't try to build your own Mac mini farm in a closet. It is not 2014 anymore. Your time is worth more than the subscription fee.
Well said. This has been a fun deep dive. It is easy to get caught up in the new and shiny, but the old and reliable still has its place. The key is knowing which one you need for the job at hand.
Thanks as always to our producer, Hilbert Flumingtop, for keeping the gears turning behind the scenes. And a big thanks to Modal for providing the GPU credits that power this show's generation pipeline.
If you found this survey helpful, we would love it if you could leave us a review on Apple Podcasts or Spotify. It genuinely helps other nerdy brothers find the show.
This has been My Weird Prompts. You can find all 1,700 plus episodes in our RSS feed at myweirdprompts.com.
Catch you in the next one.
Later. This episode was produced using Google Gemini 3 Flash, text-to-speech by Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and follow through. My Weird Prompts, that's the close from sloth, from man, from long-eared host. My Weird Prompts, until next time, stay curious, keep weirding.